Hello, my wonderful algebra kids. Welcome to our next video here. Today we are talking about writing functions. And so we're going to go from having some kind of table or set of values and how to write a function based upon that. But before we get into that, I need to fill you in on a new piece of information that we're going to be utilizing a lot this year. And so when it comes to functions, most equations we see them written as the form y equals x, some kind of something's with a y, and then it's going to equal something, and then the x has all sorts of values to change. When it comes to functions, we're going to see, instead of y, we're going to see this little symbol here. It's not really a symbol, this little value here. It's going to be called f of x. And what that means is this is the function of x. So this is whatever the function is that we're doing involving our variable. And so instead of y, you will probably see f of x, and that's how we're going to call it, as f of x. F of x. And so that's going to be how I say it, this is going to be how you write it, and this is going to be what it means. All of those are the same thing. So instead of y, we're going to see this f of x occurring a lot. They mean the same thing, basically, for all intents and purposes that you need to know and that we need to know. F of x equals y. All right, let's get on to our lesson. Let's say I have a table that looks like this right here. Let's say I have my x and my y, and my values are 1, 2, 3, 4, and these values are 5, 10, 15, 20. All right, my x and my y. Now, whenever I'm dealing with equations, my y, or my f of x, that's going to be the thing over here all by itself. So I'm going to say y equals, or f of x equals. And then we want to figure out, how do we get from y starting at x? So starting at x, how do we get from x to y? How do we get from 1 to 5? What's one way I can get from 1 to 5? Well, I can either do x plus 4, right? 1 plus 4 equals 5. So plus 4 might be an option, or 1 would be x times 5. 1 times 5 equals 5. So we want to check those based upon our x values. So we know both of these work for this first value. Let's try it for our second value. If x is 2, 2 plus 4 equals 10. No, that does not work. So let's try it down here. 2 times 5 equals 10. Yes, that works. So far we're on the right track. Let's check some more. 3 times 5 equals 15. That works. 4 times 5 equals 20. That works. All of these functions work. So we know that our equation has to be x times 5, or 5x. Okay, so we want to find one value on our table that will be easy to deal with, and then we want to solve our equation based upon that value. All right, let's try another one. Let's try another situation where we might see this. Let's say we have the table x and y. Remember, when we have these tables, we always want to figure out, what have I done to x to get to y? I'm never going to be adjusting y. I'm always going to be adjusting my x values. My x values 1, 2, 3, 4. My y values are -2, -1, 0, and 1. All right. So there are two options for me to get from 1 to -2. What's one way I can get from 1 to -2? Well, I could -3. That's one way I could get there. My other way to get there would be oh, no, my pen stopped working. I could do 1, 1 times -2 equals -2. So the two ways I could get there is by minusing 3 or timesing by -2. So if we were doing that, let's check. Let's say, all right, 1 minus 3 is -2. That works. Both of these work. Let's check our next value. 2 none of those 2's are working. It's very frustrating when things don't work the way you want them to. No. Look, we figured it out. 2 minus 3 equals -1. Hey, that works. 3 minus 3 equals 0. That works. 4 minus 3 equals 1. Those all work. Let's check our -2. 2 times -2 equals -4. Well, that's not right. 3 times -2 equals -6. That's not right. 4 times -2 equals -8. Well, those aren't right. So I have to be minusing 3 each time. So my equation would be y equals x minus 3. And there we go. Because we know that each of these values, we can minus 3, and that's going to be the equation that works with what we are doing. All right. So we are going to now talk about some more things. We're not done yet. That's part of what we're doing today, but that is not all we are doing today. We are going to be talking about independent variables and dependent variables. Okay, independent and dependent. Independent and dependent. And so what we need to know here is when we're dealing with these equations, the independent variable is known as the input, or x. The dependent variable is the output, or y. So the independent variable changes based upon whatever, or the dependent variable changes based upon what the independent variable tells it to do. Okay, so this is like in science, right? We have our variables, we have different kinds of variables. So in this one, independent and dependent. So, for example, if I were to say the faster that I drive my car, the quicker I get home. So the speed that I'm driving my car is going to change how long it takes me to get home. So the speed would be independent, and the dependent would be travel time. Because if I change my speed, that affects my travel time. If I change my travel time, that's not going to affect my speed. Me changing how long it's going to take me I can't do that. I can't just decide that it's going to take me longer. I have to change something else in order for my timing to change. So in this case, it has to be speed. Let's say that the more hours, so when you get a job, you might work a job that's hourly, which means the more hours you work, the more money you'll make. And so in that case, hours would be independent because you get to decide how many hours you work. And what happens if you work more or less hours, your money will change depending on how many hours you work. You can't just decide you want to make more money. You have to actually work harder to make more money. Okay, so that is independent and dependent. So you're going to be finding different instances where independent and dependent variables are changing each other. And so when we're talking about equations, we want to write these as change my size here. The dependent variable is a function of the independent variable. That didn't work as well as I wanted to, but the dependent variable is a function of the dependent variable is a function of the independent variable. So that means that when we adjust our independent variable, our dependent variable will change as well. Think about it like, and this is going to be where you get to see some of Mr. Sankey's really, really good drawings. Here, we're going to make this box that has like a entry point here. This is where we pour all of our good stuff. And then here is where it comes out of. Okay, so think about like a factory. Okay, you put things into the top of our factory here. You put things into this box. This is the input. So values go in here. Like 5 or 0 or 10 or whatever x values we want to put in. And we're putting them into our function. Our equation is going to be what is in the box. So this whole box is our equation. And this equation will say f of x equals 2x. So we put our x values in, and they get mixed into this equation here. And then the things that come out of it are what we solve based upon those x values. Things like 10, 0, and 20. Those things are coming out of the chute when we're putting these values into it. So they go in here, they get mixed up into our equation, and they come out with the answer. All right. I don't know if that is too confusing or not, but if we were to work on that in not a weird picture mode, we would say, all right, let's say I have f of x equals 5x. And I want to know, what is my answers when x equals 6 or x equals 7.5? Well, I'm going to plug these in to my equation here, two separate equations. F of x equals 5 times 6. F of x equals 5 times 7.5. This is going to get me f of x equals 30. This is going to get me f of x equals 37.5. That's just doing some quick math, and we can solve 5 times 7.5. All right. I want you, on your own, to solve for me. Let's say that x equals 2. You solve this equation for me. 2.3x plus 10. Plug that information in, solve that out for me, and that is your answer to move on to tomorrow. Best of luck. If you have questions on this, please let me know. We will go over some more things in class tomorrow, but good luck.